Okay, another nice summary by the World Resources Institute. They take many reports and some latest papers and put together this nice graphic representation from a paper. By the numbers, the climate action we need this decade. Whenever we say climate action and a timeline, we mean to stay under the global warming targets 1.5, 2 degrees C, and so on. I have ranted elsewhere about why they're not scientific, but it doesn't matter. The actions to keep the warming as low as possible is desperately needed in any case. And in the background, I think this is France, because it says here Atravas no Verde. Oh no, that has to be some South American country. But nonetheless, let's read what it has to say. It's a short report, so I'll read the whole thing. What are NDCs? Countries are set to announce new NDCs under the Paris Agreement by early 2025, because the earlier ones were submitted by most countries, and then it turned out that they are not sufficient to meet these targets that were set. Updated every 5 years, these pledges underpin national climate action, outlining the mitigation and adaptation targets countries promise to achieve, as well as specific measures they plan to pursue. Did I stress it properly? Updated every 5 years. These pledges underpin national climate action, outlining the mitigation and adaptation targets the countries promise to achieve, as well as specific measures they plan to pursue. NDCs form the foundation of international efforts to combat the climate crisis, as we have discussed elsewhere under Assessment Report 6 and so on. But Kyoto Protocol basically failed. NDCs are more democratic, bottom-up commitments, and then there is monitoring, verification, reporting phases, and of course the 5-year revisions to make them more robust towards the global warming target. But today's commitments, even if fully implemented, put the world on a course for 2.6 to 2.8 degrees C of warming by 2100, with a certain probability, let's say 67%, and increasingly catastrophic impacts. I'm always worried about using words like catastrophic, but nonetheless 23, 24 have been a good indication of how bad things can get when we keep warming. In this next round of NDCs, countries should set new economy-wide greenhouse gas emissions reductions targets for 2035 and stronger targets for 2030 that collectively put the world on track to limit temperature rise to 1.5 degrees C. It's realistically speaking, this probably is going to be impossible unless a real game changer comes along. Achieving these top-line targets will require rapid, far-reaching changes across the economy. To help jumpstart them, countries should also include additional sector-specific targets within their NDCs. While most NDCs include pledges to reduce economy-wide GHG emissions, fewer have featured time-bound, quantitative sector-specific goals. So, there are lots of wordings involved that they will reduce carbon intensity of the GDP and not absolute emissions, and then baseline is used as either 1990 by the most stringent countries like UK, or 2005 maybe by some other countries. I won't name them, but you get the idea. Transformational changes needed across the power sector then to stay below 1.5 degrees C. So we'll basically jump to figures showing each sector that is highlighted in this brief report, and it's obviously not comprehensive, but gives you a good sense of the biggest emitting sectors and what is needed to stay below 1.5 degrees C. So most recent historical data is shown for various things, lower range of targets and upper range of targets. So you want to be stricter about 1.5 or let it lapse a little and go towards 2 degrees C, then obviously you need more stringent actions based on which target you choose. So share of zero carbon sources in electricity generation in 2030, it was 2023, it was about 40%, sorry. 2030 target has to jump up by 125 to 133%, and if you want 2035 target dates, then more than 150% compared to 2023. Obviously, the longer you go, the more you need to reduce. Share of wind and solar in electricity generation, less than 20% in 23, needs to jump up to almost 60% or so for lower range, and upper range was going to be about almost 80% by 2030, whereas for 2035 it has to jump to about 65 and 85. All makes sense, right? There are lots of details involved in how you calculate these, because a lot of definitions are involved, a lot of projections, calculations, estimations, etc. are involved. But it's always a moving target, so we have to adjust these anyways. But 2030 is right around the corner, and 2035 is not that far off, so we must be on these pathways either way. Share of coal electricity generation, 2023 was still over 30%, almost 35%, but by 2030 this has to drop by 89% to less than about 5% of the energy production power. 2035 has to drop by 97% compared to 23, and at about 1 or 2%, which is huge co-benefits in terms of health and so on. Share of unabated fossil gas in electricity generation, obviously 2023 was over 25 or so percent. 2030 has to drop by a lot, 69 to 78%, down to 5 or even more at 7%, and 2035 has to drop by 91% compared to 23, down to about 2 or 3% of the power generation. Carbon intensity of electricity also has to be tracked in terms of grams of CO2 per kilowatt hour. In 2023 it was quite high at 490 or so grams CO2 per kilowatt hour. Has to drop by 2030 to about 50 or even 80 for depending on the upper ranges of the target, and by 2035 it has to drop to about 10 grams per CO2 of kilowatt hours. So we will end up using fossil fuels in some form for a while, because we are not quite decarbonized, and that means you just need to reduce the carbon intensity of electricity generation. Removing coal is one way, but carbon capture and other things may also work, which we will look at separately. Transformational changes. So here we always use transformational as a word which has got a definition, but let's not worry about it right now. Transformational changes needed across the building sector to stay below 1.5 degrees C. So another big emitting sector. Most historical data, lower range and upper range. So energy intensity of buildings has to drop by 17 to 41% by 2030, and 2035 estimates are not available yet. Carbon intensity of building operations in kilogram CO2 per meter squared of space. 2022 it was close to 40 kilograms, and by 2030 it has to drop by 58 to 66% compared to 2022, and 2035 estimates will be reported later. Retrofitting rate of buildings percentages per year. 2019 number is given. 2030 has to jump up by 150 to 250% compared to that baseline, and by 2035 it has to go also 150 to 250% plus, so more than 250%. So you can see they are the same numbers. You can go and see the methodology to see why that is so. Share of new buildings that are zero carbon in operation. 2020 was a tiny number at about 5% or so. By 2030 it has to jump more than 1,000%, and 2035 offers a similar number. We'll be doing great if we are jumping up by 1,000% by 2030, then 2035 will be easier. Transformational changes needed across the industry sector to stay below. So industry can be split into steel, aluminum, cement, etc., but they haven't done that. So let's just look at share of electricity in the industry sector's final energy demand. 2022 was around 29% or so. By 2030, electrification has to jump up by 21 to 48%, and by 2035, it has to jump up by 48 to 59% compared to 2022. Electrification, 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 but keeping in mind that power sector itself has to be cleaned up as well. Just electrification is not going to help. Carbon intensity of global cement. Oh, we did separate cement and steel. Global cement production, I don't know why I forgot that. I read these things before. Sometimes I read and then I wait for a month to summarize the report, so I forget. Carbon intensity of global cement production in kilogram CO2 per cement was over 600 in 2020, but has to come down by 45% or so by 2030, and 2035 target is not estimated yet. Carbon intensity of global steel production, again crude steel, that was at almost 18,000 kilograms CO2 per ton of crude steel. By 2030, that has to drop by up to 30% from 2023. 2035 is not estimated yet. Green hydrogen production in millions of tons, it's very tiny, 0.027 million tons in 2021. By 2030, this has to jump up more than 30% to about 59 million tons or so. 2035 target. Green hydrogen is basically where you are, let's say, electrolyzing water to split, get H2 out by using green energy. And there is also now something called turquoise hydrogen, which Japan is pumping up on, where you electrolyze methane but then do it in a clean way, and the amount you can do is, and there are pros and cons as usual. Transformational changes needed across the transport sector, another giant emitter, to stay below 1.5 degrees C. Number of kilometers of rapid transit per 1 million habitats, kilometer per 1 million. 2021 was at 20 kilometers per million habitats. By 2030, this has to jump up by 90% to almost 38 kilometers per million habitats. Okay, so that is the rapid transit. Number of kilometers of high quality bike lanes per 1,000 inhabitants. Bike lanes in 2020, it was a tiny 0.0044 kilometer per 1,000, but this depends on how you average, because global numbers are not meaningful. Copenhagen, Amsterdam, and many other cities may be doing much more, but now we need to worry about global mitigation. So 2030 target has to shoot up by over 30% compared to 2020 at 2 kilometers per 1,000 inhabitants. That doesn't sound like a lot, but it can make a huge difference if people just skip cars and other transportations for bicycles. And mixed neighborhood designs can also add to more use. So there is a kilometer lane, and then how many people use it also matters, right? And sector connectivity, last mile connectivities can make it much more useful. Share of kilometers traveled by passenger cars in percentage of passenger kilometers. So 2019 was almost 45 or so. In 2030, it has to drop by over 22% for lower range, and almost all of it has to drop by the upper range of the targets. And share of electricity vehicles in light duty vehicles. So this is harder to achieve for many technical reasons, and you have almost 15 or so percentage of electric vehicles. In 2023 you had 15% or so under LDVs, light duty vehicles. 2030 target has to jump up by almost 700%, up to 78% to 95%, depending on its upper range or a lower range. And 2035 up by 730%, so basically 100% of the EVs, 100% of the LDVs have to be EVs. Okay, but more on transport. Share of electric vehicles in light duty vehicle fleet, share of electricity vehicles in 2 and 3 wheelers. This is very relevant for India. You can see that even in China, so it was about 45%. It has to jump up by 66% by 2030, and by 110% to almost 100% by 2035. Share of battery electric vehicles, plug-in hybrid electric vehicles, and fuel cell electric vehicles in bus sales have to go up by 1,000% or more for 2030 and 2035. Okay, almost 90% here, 85 or so. Share of battery vehicles, plug-in hybrid and fuel cell in medium and heavy duty commercial vehicles. Tiny percentage in 23, but has to jump up more than 1000% in 2030 and more than, even more than that by 2035. So you want to have more than 60% of the medium and heavy duty commercial vehicles sold to be battery or electric or plug-in hybrid or fuel cell. Okay, share of sustainable aviation fuels. This is kind of a attempt that's going on, and not many people are optimistic about it, but here is what we would need in terms of global aviation fuel supply percentage. It was only 0.1% in 2022, has to jump up to more than 13 or so, 1000%, and over to 28 to 32% or so by 2035, and share of zero emission vehicles in maritime shipping fuel supply. So 0 in 2018 baseline, 2030 that has to jump up to 5%, and 2035 target is not decided or estimated yet. Transformational changes needed across the forest and land sector. Again, deforestation obviously has to drop by 65 to 70% by 2035. Peatland degradation in millions of hectares, these are millions of hectares per year, has to drop by more than 100% over 2020 to 2030 compared to the 1993 to 2018 target, and they have to basically, degradation has to reach 0% by 2030 and then remain at that for 2035. Mangrove loss in hectares per year, so fairly large number as of 2017 to 2019 average, but 2020 to 2023 that has to drop by 85%, and similarly for 2035. There are a lot of co-benefits of mangroves that I've discussed elsewhere in terms of blue carbon sequestration, protection against cyclones, cleaning the waters, fisheries, etc. Reforestation in millions of hectares. There has been a total gain over 2000 to 2020, but this has to go up by over 77% for the 2000 to 2020 period. Go up by 77% for the 2020 to 2030 period, and if you add 2035 then it has to jump up by 115%, so you can see the millions of hectares here. Peatland restoration in millions of hectares, there was 2015, by 2015 there was basically zero restoration. 2030 has to go up by 1000% to 15 million hectares, and by about 18 or so by 2035, or at least the average over 2020 to 2035 has to be almost 18 million hectares. And finally, mangrove restoration as opposed to mangrove loss, total direct area gained in hectares was about 10,000 hectares. 2030 it has to jump up by 1000% to over 250,000 hectares, and 2035 target is not available yet. Transformational changes needed across the food and agriculture sector, which emits over 25% of the total emissions. So you look at greenhouse gas emissions in grams of CO2 equivalent per 1000 kilocalories. So you include N2O and methane in that. So obviously has to drop by 28 to 35% by 2035. Crop yields have to jump up compared to 2022 per hectare in terms of tons per hectare by 16% and 22% for 2030 and 2035 respectively. Ruminant meat productivity in kilograms per hectare, environmental footprint of ruminant meat like cattle and other ruminants has to be reduced up 14% from 2022 by 2030 and up 21%. So that's just enhanced productivity per hectare of land use, right, for various operations of that food processing system. Share of food production lost has to be reduced by 50% by 2030 and 2035. Food waste has to be reduced per capita by 53% by 2030 and more. Food waste produces about 6% of the total waste, of the total emissions, which is not good. Ruminant meat consumption in kilocalorie per capita per day, can it drop by 21% or 26% by 2030 or 2035? Well, how do we do it? Is it through processed meat, plant-based meat, artificial meat? Various terminologies used, not processed meat, and there are issues of nutrition, side effects, various other things involved, and this cultural mores of eating meat for various reasons, and protein source as well. We have to worry about that. So transformational changes needed for technological carbon removal to stay below 1.5 degrees C. So we are talking about CCS, carbon capture and sequestration, in millions of tons of CO2. 2022 was a tiny 0.6 million tons of CO2. 2030 target has to be up by 1,000%. For lower range, it's a relatively small number, but for the upper range, it has to reach over almost 700 million tons of CO2 per year. 2035 has to reach in the upper range of targets more than almost 1,700 million tons of CO2, so 1.7 gigatons. So ultimately, CCS can be a major player only if it reaches gigaton scale, because we are emitting at gigaton scales, and we have still got a long way to go in terms of scalable technology. Many have been deployed, but they are all in tiny numbers so far. So with that background, how do we actually go from just talking about these things and to reality? So moving from rhetoric to reality, as the deadline to submit their new NDCs approaches, countries are grappling with how they will transform their economies to drastically cut emissions and meet development goals, and what time frame will this happen, on what time frame. By communicating ambitious, time-bound and sector-specific targets within their forthcoming national climate commitments, countries can demonstrate to the world how they will approach this fundamental challenge. Now is the time to seize the opportunities present in every sector of the economy. Time is pressing and stakes couldn't be higher. So let's get to work, right? So it's a nice summary, so I wanted to read off lots of numbers, but just keep the sectors in mind and note that large reductions in emissions or increases in EVs and share of bicycle, lanes and so on are needed. So we have to keep chugging along. There's no option. Okay, see you in the next podcast.